Today our do now is to complete number 1 on page 6, so pause the video, complete number 1 page 6, and we'll get right to it. Here on page 6, number 1, we're starting with our translating. Remember, unless it specifies a specific variable, you can use any letter for our variable. So 2 less than twice a number, remember less than subtract, and we're going to switch the order. So that's going to be 2x minus 2. 3 times the sum of a number and 9. Sum means add. 3 times the sum, we're going to need a grouping symbol. So 3 times the sum of a number and 9. Okay. 1 subtracted from a half of the number is at least 10. Remember, subtracted from, switch the order. Half of the number, so that'd be like 1/2 x, minus 1 is at least 10. So that would be greater than or equal to 10. The difference of 4 times a number and 3 is at most 5. Difference, keep the same order. So that would be 4x minus 3 is at most 5. That would be less than or equal to 5. Now on number 2, we're going to simplify by combining like terms. Remember, like terms are either just our constants or same variable and same exponent. We are also working with PEMDAS here, okay? So first thing, we're going to get rid of the parentheses. I look into the parentheses, I can't do anything with them because they're not like terms. So we're going to have to distribute. I have to distribute the -2 to both terms, and then here the temptation is to combine the double sign. No, no, no. That's a -1. Let's distribute the -1 to both terms. So we have 4a squared minus 6a plus 8 plus 5a squared minus 1 minus a. Now if you want, you can reorder your terms so the like terms are next to each other, just using our commutative property. Otherwise, just go ahead, combine those like terms. We should have 9a squared minus 7a plus 7. And we've formatted that in standard form. Remember, the term with the highest degree, highest exponent, down to our constants. Our next one, a little more challenging because we have those fractions. My first step is going to be to rewrite the fractions so that we have them as improper fractions. So that would be -10/3 minus 5/2. Now I can't combine these, so what we're going to do is we're going to distribute, and either off to the side, or I'm thinking in my head how I'm going to multiply those, right? -2/3 times 1/5 is going to be -2/15. -2/3 times -10/3 is going to be +20/29. And I did not need that parenthesis there. Don't know why I put it there. Now, ooh, almost lost my y. Okay. Now, as I go here, I'm going to be looking for common denominator within our like terms. So a common denominator for the y's is going to be 30. So we'll go times 5 times 5 times 2 times 2. And then common denominator for our constants would be 18. So we're going to do times 2 times 2 times 9 times 9. And each like term gets its single common denominator. So let's see, that's going to be 30. So let's see, -25 minus 4, don't forget the y, and plus, let's see, 18, that's going to be 40 minus 45, -25 minus 4, that's going to be -29/30 y, and then 40 minus 45, -5/18. Everything's fully reduced and we're in standard form. On number 3, we're going to find the equivalent expression by factoring. First thing I want to remember is to write our expression in standard form first. So I'm going to rewrite in standard form. That would be 12x minus 6. Now I want to get the common factor, and I look to the numbers, I look to the variables. Common factor, greatest common factor of our numbers is 6. There's no common factor in our variables, so that's it. Now we write the parenthesis, and I think to myself, well, okay, what would I multiply to 6 so I get 12x? That would be 2x. What would I multiply to 6 to get negative 6? Negative 1. Boom, and there we are. We are fully factored. So let's do it again there. Here we're in standard form. The sum of our exponents, 5 plus 2 is 7, 4. Okay, so we're fully factored. Now our common factor here is just going to be variables. So we've got a and b. We always take the smallest exponent of each variable, which for a's is an exponent of 1, for b's is an exponent of 2. Now what would I multiply to ab squared to get a to the 5th b squared? Well, I would need a to the 4th. Okay. What would I multiply to ab squared to get b to the 3rd? ab to the 3rd, just a b. And there we are. Fully factored. And I always check inside the parentheses to double check, are there any common factors left there that I may have missed? Our third example is still in standard form. No number. Greatest common factors, just going to be the variables, and they're going to be just a and b. Those are the two smallest exponents, the exponents of 1 there. So what am I multiplying to ab to get a to the 3rd b squared? That's going to be a squared b. What am I multiplying to get negative a squared b? That'd be a negative a. What am I multiplying to ab to get 2ab? That would be a 2. Okay, so one of those just got to kind of practice to bring that process back to you. Now our last example is not in standard form. Let's rewrite it. 6x squared plus 4x plus 10. Looking for the common factor. Greatest common factor is going to be 2. No variable common factor because that last number is a constant. There's no variable there. So on the inside we'd have 3x squared plus 2x plus 5. And that would be fully factored. Okay. On number 4, we're solving our algebraic equations. Variables on both sides. Let's first distribute that 2 to simplify. 6x minus 10 equals 6x plus 8. Now something I notice here, we've got same variable terms, different constants. That's no solution. Okay, that's our answer. If you remember, right, we kind of start and we start solving, we get minus 6x, you get negative 10 equals 8. No, that's not possible. No solution. As soon as you get here and you see same variable terms, different constants, you can drop right to your answer of no solution. Okay, here let's distribute again. Now we have 6x minus 10 equals 6x minus 10. Same variable terms, same constants. That tells us infinite solutions. Okay, and as soon as you notice that, you can jump right to the answer. If you didn't notice that right away as you were solving, you would have wound up with something like this, where you get negative 10 equals 10, and that should have been a clue that it's infinite solutions. Okay, let's see here. Distribute the 2. We get 6x minus 10 equals 5x minus 10. Okay, so we just kind of solve. Variable Topia on the left, Constantinople on the right. Move my variable term first. Minus 5x minus 5x. X minus 10 equals negative 10. Add 10 to both sides, and we get x equals 0. Now there is a clue there of getting that x equals 0 equation, and that's different variables, same constants. I always miss that one, so I just always solve. Now here, a real throwback, our absolute value equations. Haven't done that in a long time. Remember, these were really cool. We had to first isolate the absolute value bars. So treating that almost as if it was a variable in the equation. So we subtract our constants. We get 2 times the absolute value of 3x minus 5 equals 2. Divide both sides by 2. We get absolute value of 3x minus 5 equals 1. Now we take what's inside the absolute value bars out and we make our two cases. We make the positive case and the negative case. So positive case, we set 3x minus 5 equal to positive 1. The negative case, we set 3x minus 5 equal to negative 1 and solve for each. Right? Add 5, we get 3x equals 6, divide by 3, and we get x equals 2. Add 5, 3x equals 4, divide by 3, we get x equals 4/3. And there are our two answers, x equals 2 or x equals 4/3. On page 7, we're working with our inequalities, okay? So one of the things I want to do here, we're first going to cancel our constant of 2.5. Okay, so we get negative 1 1/3 x is greater than 5.5. I'm going to take everything, change it to improper. So that'll be, let's see, 3 times 1 is 3, plus 1 is 4. Negative 4/3 x is greater than 11/2. Now we have to eliminate that fractional coefficient, so we multiply by the reciprocal, negative 3/4. Okay, so that's going to give us x on the left because everything cancels. Remember, we multiplied by a negative, so we have to flip the inequality. Right? When you multiply or divide both sides by a negative, you flip the inequality, and that gives us negative 33/8. X is less than negative 33/8. And now we have to go and make our number lines. We put our critical value, negative 33/8, in the middle, and then I'm going to skip a line and go by eighths, I guess. So that'll be negative 32/8, negative 31/8, and we're following right, positives to the right, more negatives to the left. Put our circle at our critical value. It's going to be an open circle because it's just less than, and where are the numbers smaller, less than negative 33/8, those would be to the left where all the negatives are. Now our interval notation, right? What's the smallest possible value of x? Negative infinity. The largest possible, negative 33/8, but it doesn't include that, so we use our parentheses. Remember, infinities always get parentheses, open circle, parenthesis, closed circle, bracket. Okay. Now we've got our compound inequalities. Here's our conjunction, our and inequality. The 3 sections, what we do to one, we do to all the others. So subtract 4 from all sections. That gives us, 4 is less than 2x is less than or equal to 12. Now we divide everything by 2. 4 divided by 2 is 2. 2 is less than x, and x is less than or equal to 6. Had that been a negative, we would have had to flip all the inequalities also. Okay. Now we need to make sure we include our 2 critical values. So let's see, why don't we start at 0, 2, 4, 6, 8, 10. Open circle at 2, closed circle at 6, right? And this is the one that looks like the dumbbell, right? We shade in the middle, the numbers that are less than or equal to 6 and greater than 2. Our interval notation, 2 gets a parenthesis because it's an open circle, 6 gets a bracket, a closed bracket, because it's that shaded, that closed circle. Our third one, we have our disjunction, our or. Remember, we solve each inequality one at a time. So I'll add 3. T is less than 5. Now I'd go to the other one. Subtract 4 from both sides. Negative 2t is less than negative 14. Divide both sides by negative 2. So we've got a flip. T is greater than 7. We had that flip. Okay, now rewrite as a disjunction. T is less than 5 or T is greater than 7. Now we'll make our, let's see, let's do 3, 5, 7. I guess I could have put that more in the middle, but it'll do. Okay, so first one, T is less than 5, so it's going to be an open circle shaded to the left. T is greater than 7, open circle shaded to the right. And our interval notation has those two parts. So we do the left part of the graph, that'll be negative infinity, comma 5 in all parentheses, because we open circles and infinities, or, right, we put that U, parentheses 7, comma infinity, close the parenthesis. Okay, so let's go on to our word problems now. We're going to write a let statement, an equation or inequality, and solve algebraically. Reed has $80. He wants to purchase a shirt for $47 and as many pairs of socks as he can. Each pair of socks is $4. Write and solve an inequality for the maximum number of pairs of socks that Reed can buy. There's our unknown, number of pairs of socks. So we're going to let X, right? Remember, we do our let statement. Number of pairs of socks. Okay. Now we're going to compare the two things, right? We're going to compare what he's, sort of buying and spending his money to money he has. So what is he buying? He buys a shirt for $47 plus as many socks as he can, and they cost $4 each. So to show each pair of socks costs $4, we'll do 4x. He has $80 to spend. When you go shopping, you can't spend more money than you have. So we can spend less than or equal to $80. Now let's go through and we'll subtract and solve. So 4x is less than or equal to 33. Divide both sides by 4. X is less than or equal to, that would be 8 1/4 or 8.25. Now, he can't buy a quarter of a pair of socks. So we must round down to 8 because X is less than. Even if it were 8.75, we still wouldn't be rounding up for 9 because he doesn't have enough money for that. So we'd say he can buy at most 8 pairs of socks. And there we go. Number 7, consecutive integer problem. Love it. Find 3 consecutive odd integers such that twice the sum of the second and the third is equal to 80. So there's our let statement. Find 3 consecutive odd integers. So we let X equal the first odd integer. Then how do you go from one odd number to the next? You add 2. So X plus 2 is the second odd integer. Right? If they were just consecutive integers, then it would just be plus 1. And then let X plus 4 be the third odd integer. Okay? Now the rest of the problem gives us our equation, right? Such that twice the sum of the second and the third is equal to 80. There's my equal sign, is equal to 80. Twice the sum of the second and the third. So that's going to be 2 times the sum of the second and the third. Well, the second is X plus 2. The third is X plus 4. Notice our equation doesn't say anything about the first number. That's okay. We can still solve for it. So solving algebraically, we'll combine like terms inside the parentheses first. That'll be 2x plus 6. So 2 times 2x plus 6 equals 80. Then we can distribute. 4x plus 12 equals 80. We'll subtract 12 from both sides. So we get 4x is equal to 68. Just going to slide my work up there. 4x equals 68. Divide both sides by 4. And x is equal to 17. And then x plus 2 must be 19. And x plus 4 must be 21. Then we're just going to state the integers are 17, 19, and 21. Okay. Last problem, last word problem. Molly has some dimes and quarters. The number of dimes is 5 less than 3 times the number of quarters. Altogether, she has $3.35. How many coins of each type does she have? Okay, so let's start with our let statement. She's got dimes and quarters. The number of dimes is 5 less than 3 times the number of quarters. There's our let statements. So we always have a let X. And we're gonna let X be the coin we have less information about. The number of dimes is 5 less than 3 times the number of quarters. That's a big descriptor for dimes, so we have less information about quarters. So we're going to say let X be the number of quarters. Okay, then that sentence describes dimes. 5 less than 3 times the number of quarters. That'll be 3x minus 5. There's our number of dimes. Now, if you remember, what we did in this unit was we went and we made a chart. We made for quarters, for dimes, we did our cents, our number, and then the value, right? So quarter is 25 cents, dime is 10 cents. Our numbers from our let statement, x and 3x minus 5, and then the value, we multiply. Notice for our dimes, we have to distribute, right? So we can do it here or we can do it in the equation, okay? Then our equation, right, we add them together, 25x plus 30x minus 50 equals, right, change this to cents, is going to be 335 cents. Combine our like terms, 55x minus 50 equals 335. Add 50 to both sides. We get 55x equals 385. Divide both sides by 55. We wind up with x equals 7. Then we just have to figure out, well, what's 3x minus 5? Well, x is 7, so that's going to be 3 times 7 minus 5, which is 21 minus 5, which is 16. Okay, so then that tells us that there were 7 quarters, 16 dimes. And there we are. So you guys should be working on pages 8 and 9 for your classwork today. Definitely use the notes as a guide. Check your answers against the answer key, and you should be submitting those on Google Classroom. Today's math jokes for Matthew folks. I had an argument with a 90-degree angle. Turns out it was right. Have a great day, everyone.